Hello and welcome to the YouTube channel D Creations Resources. These days we are looking at different concepts from science. Today let us talk about an important concept called the Hall effect. I'm calling it an important concept because it is useful for several applications including measurement of magnetic field or even in speedometers, in cars and bikes. Hall effect is used. Then when you close a smart cover of your smartphone, that time also Hall effect is used to detect that. So basically Hall effect sensors are used for that. Even in robots, Hall sensors are used. And basically it also demonstrates how electricity and magnets are linked to each other and they can affect each other. Now, in order to learn about Hall effect, instead of directly jumping into the technical terms, I am going to give an analogy. Those who do not need an analogy and need only technical explanation can skip this part, but those who would like to know it using an analogy can continue as it is. So what you can imagine is that you have a straight road with cars and the cars are moving on the road, and then imagine that there is a strong wind which has suddenly started blowing, and this wind is going to push the moving cars to one side of the road. Now let us bring in the technical terms. So when we are talking about cars, we are actually referring to electrons. And when I say cars are moving on a straight road, I mean to say that electrons are moving in a wire. Now we are talking about some kind of a strong wind which is going to make the cars move. So here actually we are talking about magnetic field, and if we bring a magnet near the wire, then the magnetic force is going to push the electrons to a certain side. Now please understand that the direction of current and direction of magnetic field is perpendicular, and the direction in which these electrons are pushed. And when I say these electrons are pushed, we also need to take into account that they are negatively charged. So had there been particles positively charged, they would be pushed directly in opposite direction. So the idea is that on one side you have the negative charges and on the other side you have positive charges. So basically a voltage is building up, and direction of this voltage is mutually perpendicular to both the direction of the current as well as the direction of the magnetic field. The voltage that has got built up is called the Hall voltage. So in simple terms, Hall effect is when a magnetic field pushes moving charges in a material to one side, creating a voltage across the material. And to talk exactly in technical terms, the Hall effect is a phenomenon observed when a current carrying conductor or a semiconductor is placed in a magnetic field perpendicular to the direction of the current. And this results in a voltage difference, which is called as the Hall voltage, being generated across the conductor or semiconductor perpendicular to both the current and the magnetic field. So there is a current carrying material and or conductor or semiconductor, whatever it is, and it is placed in a magnetic field perpendicular to the direction of the current. And the voltage that is generated as a result of this is mutually perpendicular to both the current and the magnetic field. Now the force here is the Lorentz force, and it is basically the total force acting on a moving electric charge due to both electric and magnetic field. Well, Lorentz force is very useful in understanding working of components such as motors, because motors use magnetic fields to push electricity, that means to push moving charges in a circle, making things spin. Or in case of speakers, magnetic fields are used to push moving charges through a coil, which moves a cone and creates sound waves. Or the magnetic field of the earth deflects harmful charged particles coming from the sun. So mathematically, the expression for Lorentz force is F is equal to QE plus Q into bracket V cross B. Now here F of course is the Lorentz force. Q is the charge of the carrier. So sometimes instead of Q even E is written. Capital E is the electric field, and V and B are basically the drift velocity and the magnetic field. Now if you just want to talk about the magnetic force experienced by the charge carriers, it is the second part in the formula, that is Q into bracket V cross B. So when I say V cross B, it's a cross product, so it essentially means VB sine theta. So if the angle theta is 0, that means if V and B are in the same direction, obviously this force will be 0. But in the case when V and B are perpendicular to each other, sine 90 will be 1 and it will be the maximum that it will encounter. So this is just the basic idea of Hall effect. We'll talk in detail about it in the next episodes. Thank you.